Morning everyone, I am Sai Krishna from CSM AML Section C Institute of Aeronautical Engineering. Today my topic is homogeneous recurrence relation. Subject ordinary differential equation and vector calculus. Introduction to recurrence relation. A recurrence relation defines a sequence where each term is expressed as function of its preceding terms. Homogeneous recurrent relations have no constant or recursive function in terms of the right hand side. They model discrete time systems such as algorithm complexity, population dynamics, digital signal processing. The general forms solving such relation is closed from expressing instruction for performance analysis in AI and machine algorithms. Order and degree recurrence relation. The order of recurrence relation is the difference between the highest and lowest indicia of the sequence terms. For example, is a second order relation that refers to highest power and the sequence terms. Typical linear degree in homogeneous cases. Higher order relation requires more initial conditions to uniquely determines solution engineering application. Second order relation for model oscillatory or damped systems in discrete time. Linear homogeneous recurrence relation with constant conversion. The relation have the form with constant coefficient linearity my superposition are the solutions. So constant coefficient ensure time inverse crucial for modeling stable digital system. Such relation arise in difference equation in discrete analogs of differential equation. They are foundational in analyzing recursive algorithms, infinite impulsive filters in signal processing. Characteristic equation method. To solve assume a solution form substituting yields characteristic equation. The roots of this polynomial determine the form of the general solution. For distinct real roots, the solution. This method part is solving linear odds with constant coefficient emphasizing mathematical duality. Case 1 distinct real roots. When the characteristic equation has k distinct real roots, the general solution is a linear combination. The solution takes the form constant a are determined using k initial condition. The case models are non-repeating exponential behaviors common in stable recursive system. Case 2 repeated real roots. If a root R is has multiple TM contributes terms, for example a double root R leads terms in the solution. This accounts for polynomial growth modeled by exponential or growth. Repeated roots arise in critical, damped, discretization or degenerate algorithm cases. Example: AN4 minus. Complex conjugate roots. Complex conjugate roots conjugate pairs leading oscillatory solution using Euler's formula. The real solution becomes and this module understands systems such as digital oscillator or periodic algorithms, examples, etc. Solving with initial conditions. Initial conditions are substituted in the general solution to solve for constant. This results in a system of k linear equation of k union known coefficient. The matrix or substitution can be used to solve system equation. Accuracy in initial condition critical for correct long-term behavior prediction. Example application and occurrence relation model time function divide and conquer like merge sort. Example Dn is non-homogeneous but homogeneous forms appear in simplified cases. Solving yields 0 n log n complexity essential for evaluating AI algorithm efficiency. Homogeneous versions help isolate recursive structure before adding non-recursive terms. Understanding growth rates, exponential and polynomial guides optimization in ML files. Digital signal processing, homogeneous recurrence relation model, the natural response of linear time LTI system in DSP. They represent impulse response of system described by difference equation. The solution reveals system roots inside the unit circle implies stability used in IR where output depends on past output. Example, decaying exponential response. Connection to differential equation. Recurrence relation are discrete along the differential equation both parasitic. The shift operator balance divider operator solution involve exponential and OD and geometric sequence. Recurrence stability analysis uses eigenvalues root magnitudes. This duality enables cross-domain modeling in hybrid continuous discrete system. Multiple interdependent sequences lead to vector recurrence relation. Solution involves eigenvalues eigenvector of matrix. Diagonal simplifies computation used in Markov chains, neural networks, state evaluation, multi-agent system. Stability depends on spectral radius 1 for convergence to 0. Summary and engineering elements. Homogeneous recurrence relation provide closed form solution for discrete dynamic system. Solution method rely on characteristic question and root analysis. They are vital in algorithm design, DSP, control system, and AI model. Understanding growth and stability helps optimize computation efficiency and robustness. Mastery bridges discrete mathematical and practical engineering AI and ML application. Thank you. Institute of Aeronautical Engineering. Thank you.